cannot demonstrate this stuff because I can't get to Azure from this room, although next week we should be able to do it from Science 37. But let me just tell you about the other project. Once you've got a Windows server, either local or on Azure, then you can make it a DNS server. So first you install Wireshark, which is a free packet monitoring utility you can put on any operating system, and you can put it on Windows. Then, before you do anything, your machine is connected to the internet as usual. So you can use NS Lookup, which is Microsoft's equivalent of Dig. It has less features, but it can do lookups. So you can look up ccsf.edu, and what you'll see is it finds an address for ccsf.edu, but it's a non-authoritative answer. This is what most of your answers are. You ask your router asks and finds one of the name servers, but not necessarily the start of authority name server. So it's telling you it's not an authoritative answer, but it is an answer that it found, and usually that's good enough. So now you check your IP address. Yeah.
Can you explain a little better the difference between an authoritative response and non-authoritative?
Yes. An authoritative response comes from the one server marked start of authority. That is defined as the master copy. The other servers have copies of that data.
So in case of CCSF, where the authoritative?
You can find out. Let me demonstrate that. If you go here, if you do dig of ns for ccsf.edu, it'll show you a name server for ccsf.edu, one of the random name servers. But if you dig SOA, it will tell you which one is the authoritative server. And so now if I dig at, say, Cloudflare, which is 1.1.1, and I look for www.ccsf.edu, this is a non-authoritative answer. Authority 0. It got an answer, but it got it from Cloudflare, and Cloudflare is not authoritative about ccsf.edu. But if I go to this authoritative server, which is this one, not quite sure which of those names I should use. Let's try this one. So if I do this, dig at that, now, still authority 0, so I think maybe I needed to use the other one, which was this longer name. There. Let's try that. Well, I've got it in the projects. So I don't... Yeah?
Can you close that remote desktop, please?
Remote desktop? Yeah, might as well close it. Oh, it's on front. Oh, whoa, I'm not projecting the right screen. Pardon me. That's why you're not seeing anything. All right, here's, let me try this again. And also I've split my window and I don't know how to unsplit it. I'm just going to close it and reopen it. All right. And this is in fact coming up in one of the projects. All right. So if I dig ccsf.edu, I get an answer. But if I get the SOA for ccsf.edu, that's here. And I think that is a real server. Let's try getting that. Yep, there's the address. All right. So if I dig at that, and then I go for, say, ccsf.edu, I expected it to be an authoritative answer. I'm not quite sure why I'm not seeing it here. I know how to do it in Windows, but if I go to the authoritative server, it should tell me it's an authoritative answer. Oh, I didn't get an answer. That's why. Recursion requested but not available. Okay. I'd have to do a different query. Anyway, let me point to the official project, and we'll get back to this later. Later I'll have a better demonstration of that. Anyway, so this is what you have with a recursive query to get a non-authoritative answer, which is what you're normally using when you surf the internet. So now you find you're going to make a DNS server. When you do that, you have to have a static address. You're not supposed to have a DNS server on a dynamic address because it's supposed to stay at a fixed address so people can find it. So you have to record your address and then assign it statically on your Windows machine, just so it stops changing. And then you set your DNS server address to 127.0.0.1. This means from now on, resolving DNS is going to go to your machine, not to the internet. Now that might sound crazy, and it should, because if you don't go to the internet, how are you going to find anything? And that's an interesting part of this project. So now, after you do that, if you try to look up ccsf.edu, you can't find it, because it looks for your own machine for the answer, and your machine is not providing that answer because it's not a DNS server yet. So now you have to make it a DNS server. You do it in Server Manager. This is a default window that opens every time you open a Windows server, is Server Manager. And so you go and add role-based services, and you can just add the DNS server role to your machine. There's all these things it could be, and one of them is a DNS server. So you just check the DNS server box and then click next, 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 and you'll get a default DNS server, which is a recursive resolver, just like your browser, just like your router at home. So after you do that, now, when you look up ccsf.edu, it will look at 127.0.0.1, which is your machine, and it will find it, but it will be a non-authoritative answer, just like your router. So, and now, I was sort of confused. I still didn't tell about any DNS servers on the internet at all. So how did it find anything out? And you can find out by following the traffic in Wireshark. Wireshark shows you the raw network packets. So you filter for DNS, you perform that lookup, and you will see all the queries. This is where it's very nice. What it does is you get an answer, no such name, and it's going to ask a lot of queries all over the place, but the first place it looked was 192.33, 4, and 12. And I wondered, where did it get that number? That is one of the root servers, and you can find it in your server. Those are called root hints. If you go to your DNS manager, you can view the properties, and you'll find root hints. Here they are. Built into the DNS software is the hard-coded IP addresses of those top 13 servers we talked about. That is the only thing your DNS server knows, is the top 13 root of DNS servers. And so when you try to find anything, it starts at the root and says, where is .net, and goes step by step. So that's the story. That's what this process up here is. It asks at the root, and the root sent it somewhere. I was looking, I think, for yahoo.com. Yeah, yahoo.com. So it went to the root, and then it went to a whole bunch of different DNS queries had to be made to track it down. But since it knows where the root of DNS is, that's all it needs to know. It asks the root of DNS where .com is, it asks .com where yahoo.com is, and then it asks that where the particular server you were looking for was. So that's how it works. This is how you make it. And now you can make an authoritative DNS server. I was able to do this on Windows. When I just tried to do it on Linux, for some reason it didn't work. But here you do NSLOOKUP and you find the SOA for ccsf.edu. And this is it's really ns3.ccsf.edu. So something weird happened with my SOA. But anyway, then what you do is you dig ccsf.edu from ns3.ccsf.edu, and now you don't have that non-authoritative server message, which is how Windows indicates it. So let's try it in my Linux machine here, see if I can do the same thing. It's dig at, this is Mac, dig at ns3.ccsf.edu, ccsf.edu. And I get no reply at all. That's rude. There, no servers could be reached. So this is something funny about the City College Network. So anyway, if I use the looking glass, it'll probably work. Let's get the, There. Let's try it here. Dig at ns3.ccsf.edu, and I want to look. I think I put it here, ccsf.edu. There. This might work. Yes. See, now I get a non-zero number for authority. So now I got the answer with some authority. And if I dug a different server, I would not have the authorities. If I went to a different server like 1.1.1.1, then my answer would not have authorities. So, all right. That's what I wanted to see. It looks a little different.
Number 4 earlier.
Yeah, what was that?
Number 4.
Yeah, you want to see that? Yeah. That was a little funny, isn't it? That was NS3. I don't know why it was 4. That's what confuses me. I got to look up and see what part of this tells me the authority. It tells me authority 4, which means there are 4 servers here. But I don't know. I expected, so I'm going to have to look up how it indicates an authoritative server in DIG. It's more complicated than NSLOOKUP. Anyway, all right. So that's what I wanted to show you. And I think there might be a little more to do on this one. D2, there we are. Making a DNS server. So that's it. You find a text record from my server to show you made it. And then you can start a Wireshark capture and perform a reverse DNS lookup, where you look up an IP address. And here you hit a problem we're going to talk about more as we go ahead. This is a private IP address, 192.168.1.1. No server can have that address, no public server. So it doesn't make any sense to do a reverse lookup for that address. And if you try it, it will find a non-existent domain. Wireshark, unfortunately, Microsoft did something nasty to the internet. Every time a Microsoft machine boots up and gets a private IP address, it sends a reverse lookup like this, which typically goes off to the internet. There's a gigantic flood of millions of these stupid requests asking for public addresses for public domain names for private addresses. They are a huge problem on the internet. And you can see that if I try to do this lookup for a private address, here's my Wireshark showing all these queries going off to public addresses, root servers and other addresses, hunting for this private address, which it's never going to find. This is one of the nasty things Microsoft did to the internet. So there's a flood of these packets, and there's a whole system of servers just to deal with this flood of traffic, which would amount to a denial of service attack. So what you're supposed to do, which for some ungodly reason Microsoft does not do by default, is when you make a recursive resolver, you're supposed to tell it not to go hunting for private addresses. And to do that, you have to manually create these authoritative reverse lookup zones. And you have to make like 12 of them. Here's the one that handles 192.168, here's 172.16, 172.17, and that should go all the way up to 172.31, and here's 10. You have to do it by hand. And if you do this, then your server will know not to ask anybody else where those addresses are, but just give me an answer. And now, if you do that kind of reverse lookup again, it will not send any packets off your machine. So this has been irritating the Linux community for like 30 years, or 20 years anyway. Ever since Microsoft did this, Microsoft didn't implement DNS correctly in Windows, or for that matter, DOS, and they never fixed it. And there's a whole angry crowd of Linux-based people designing servers just to get rid of all these stupid queries that are clogging up the internet. The IANA black hole servers and otherwise. Anyway, so you set that up here on your Windows server. And I'll try and have it set up to do it live next time, but I can't do it right now. So that's all I wanted to put in the recording.